Hello and welcome. This is Bijan Hushiar. This internet network is configured with IPv4 addressing and routing in order to establish end-to-end connectivity. PC1's IPv4 address is 192.168.1.1. PC1B has the IP address of 192.168.1.2. Server 2 has the IPv4 address of 192.168.2.2. PC2 has the IPv4 address of 192.168.2.22. Server 3 has the IPv4 address of 192.168.3.3. Let's go ahead and test end-to-end connectivity. From PC1A, we are going to ping server 3 to see if we receive replies back. The IPv4 address of server 3 is 192.168.3.3. 4 echoes were sent by PC1A, and echo replies are coming back. There is end-to-end connectivity there. Let's see if we can ping server 2 from PC1A. 4 echoes are going to be sent, and we expect 4 echo replies coming back. There is end-to-end connectivity there. Let's see if it can ping PC22. The IPv4 address of PC2 is 192.168.2.22. Replies are coming back. There is end-to-end connectivity on that device. Let's test PC1B to see if it can access PC2. We ping 192.168.2.22. We receive replies back. Let's see if it can ping server 2. Replies are coming back. Let's see if it can ping server 3. Replies are coming back. Let's see if this PC can access the website on server 3 and server 2. We go to the web browser of PC1B, and then in the URL we type the IPv4 address of server 2, and then hit go. It can access that website. Let's see if it can access the website of server 3. We go back to the web browser. In the URL, this time we type the IPv4 address of server 3, which is 192.168.3.3. Go. We can access it. Let's see if PC2 can access the website of the server 3. We go to web browser of PC2. If it can access the website, then definitely it can ping it also. 192.168.3.3. Let go. It can access that website. Let's see if server 2 can access the website of server 3. We go to the web browser of server 2. In the URL, we'll type the IPv4 address of server 3, 192.168.3.3. Hit go. It can access the website of that server. So there is end-to-end connectivity. There is no access control list filtering traffic. yet, but our objective is to create access control lists to filter traffic from a particular source device to a particular destination in the continuation of this activity. Our objective is to create extended IPv4 numbered access control list to allow PC1A access the website of server 2 to prevent PC12 from accessing the website of server 2. Also, we want to prevent PC1A from pinging server 2, but we want to allow PC1B to ping server 2. It is recommended that extended access control is to be applied to an interface close to the source of traffic. In this case, G01 of router 1. Therefore, we have to create access control list on router 1. We access router 1's command line interface. We go to privilege mode. We perform show access dash list to see if there is any access list existing on this router. None exists. We go to global configuration mode, conf t, and we want to create extended numbered access control list. The command is access dash list, and then since it is a numbered access control list, we have to provide a number for it after access dash list. The numbers that can be used are 1 through 91, 1 through 99 if you are creating a standard access control list, and 100 through 199 if we are creating extended access control list, as long as the number is not already used by another access control list. In here, we want to create extended, so the range of numbers available to us to apply to this access control list is between 100 and 199. None of them has been used, so I'm going to start with the first one, which is 100. Access dash list space 100. Then I want to permit TCP host. Which host? PC1A. What IPv4 address? 192.168.1.1. To access as a destination host. Which host? Server 2. What IPv4 address? 192.168.2.2. What type of traffic? HTTP port 80. I want to deny PC1B from HTTPing to server. So I add another statement or command. Access list, same number, 100, deny host. What host? PC1B. What IPv4 address? 192.168.1.2. From reaching which host? Server 2. What IPv4 address? 192.168.2.2. What type of traffic? HTTP. A TCP host, not just host. Now, I want to prevent PC1A from pinging the server. I need to add another statement or command. Access dash list, same number, 100, deny ICMP. That's the protocol being used for pinging. ICMP host 192.168.1.1. Which host? Which destination host? Server 192 168.168.22 echo, as far as the type of traffic is concerned, because ping sends 4 echoes by the initiating device, and the destination device replies back, and those replies are called echo replies. But we are filtering from the initiating device, we use echo. If we wanted to prevent server 2 from replying back, we would have changed the source and destination IPv4 addresses, and then we would have put echo reply at the end. So access list 100 deny ICMP host 192.168.11 host 192.168.22 prevents PC1A from pinging the server. But I want to allow or permit PC1B to ping server 2. The command is access list 100 permit ICMP host 192.168.12 destination host 192.168.22 echo. If I don't add any other command or a statement to this access control list, every traffic will be denied because there is an implicit deny any at the end of each and every access control lists. So I need to add a permit command to allow other types of communications. That command is access list 100 permit IP any, because some communication may come from another network, and some communication may start from another device within network 192.168.102 towards that destination that we want to allow. So I add this one, then I'm going to access interface G01 of router 1 and apply this access control list to that interface with this command IP access dash group 100 in, because packets are going to go into G01 in order to be forwarded towards the destination network. That's it. Let's put it to test. Let's see if we can access the website of server 2 from PC1A. We go to the web browser of it and we type 192.168.22. We should be able to access that website. Are we able to ping it? Let's put it to test. Destination host unreachable because we denied that. Let's go to PC1B and see if we can access the website of the server 2 by typing the IPv4 address of the server 2 in the web browser of PC1B. We should not be able to access it. It's taking long, but it's going to refuse us from accessing the website because we denied this PC from accessing. Request timeout, meaning we are not allowed. Let's see if we can ping that device. Ping 192.168.22. We should be able to ping it because we allowed it. The replies are coming back. Now, the permit command that we put at the end of the access control list, access list permit IP any, would allow any of these two PCs to ping PC2. Without that, we couldn't. So let's go ahead and see if we can ping PC2 from from PC1A. The IPv4 address of PC2 is 192.168.2.22. Replies are coming back. That permit command would allow this. And let's see if we can ping PC2 from PC1A. Yes, we can. So that's how you create uh, an extended IPv4 numbered access control list and how you apply it to an interface of a router. Now that we have created this one, let's go back to uh, privilege mode and perform show access dash list. Oh, we have created one access list on this router. It is numbered. It is numbered 100, therefore it is extended. Since it is numbered, it is IPv4. And these are the statements in that access control list. If a traffic gets to router 1 through G01, first, this statement is going to be read by the router. If it applies to the traffic, we'll apply it. Otherwise, we'll go and read the second statement. If it applies to traffic, we'll apply it and ignore everything else. Otherwise, it will go and read the third statement. If it applies to the traffic, we'll apply it and ignore everything else. Otherwise, it will go and read the next statement to see if it applies to the traffic that it has received. If it applies, fine, ignores everything else. Otherwise, it will go and read the last statement and apply that one to traffic, which is permit IP any. Had we not included that one, any other type of traffic would have been denied also. Now I want to show you how to remove access control list. We have created an access control list extended numbered IPv4. So we go to global configuration mode. First, we access the interface G01 and remove. We apply the access control list to this interface. We want to remove it. No IP access dash group 100 in. We remove it from there, from that interface. We go back to global interface and we say no access dash list 100 and we remove that one. Let's see if there is any access control list to show access dash list. No access control list exists right now and we removed all of them. Let's see if PC1A can ping the server right now. If it can, we have removed the access control list that we created previously. So we learned how to create extended numbered IPv4 access control list, how to apply it to an interface, and we tested it and verified it, and then we removed it. Next, we are going to create named IPv4 access control lists. Now I want to create extended named access control list to allow PC to access the website on server 3 but not be able to ping it. Additionally, I want to deny server 2 from accessing the website of server 3 but be able to ping it. I need to create an extended access control list. I want to create an extended named IPv4 access control list. I need to apply it to an interface as close as to the source of traffic based on the recommendation that we have. So I'm going to apply to G01 of router 2. Therefore, I have to create the access control list on router 2. But first, let me see if we can ping and access the website of the server 3 from PC2. We are going to ping that server, which has the IPv4 address of 192.168.3 from PC2. Replies are coming back. Let's see if we can access the website on that server from PC2. We go to the web browser of the PC2, and in the URL we type the IPv4 address of that server 192.168.3.3, and then we hit go. We can access it. Let's perform the same test on server 2. We go to the web browser of server 2, see if we can access the web server on server 3. After the browser opens on server 2, we in the URL, we type the IPv4 address of server 3, which is 192.168.3.3, and we hit go. We can access it. Can we ping server 3 from server 2? Yes, we can. So there is no access control list right now. Just to verify, the IPv4 address of the PC2 is 192.168.2.22. The IPv4 address of server 2 is 192.168.2.2, and the IPv4 address of the server 3 is 192.168.3.3. Now we can go ahead and start creating named or extended named IPv4 access control list on router 2. We access the command line interface of the router 2, enable, and we perform to see if there is any accesses. If there is, we remove it. Show access dash list. There is none. We go to global configuration mode of this router, and then we start creating named IPv4 extended access control list with this command, IP access dash list. And after that, I have to indicate that this is an extended access control list with this keyword, extended. And after that, I have to give it a name. I'm going to call it PC2 web access. Okay. After that, I need to add the commands or statements to this access control list called PC2-web-ACC. I want to permit TCP host. What host? What source host? PC2. What IPv4 address? 192.168.2.22 to reach a destination host. Which host? Server 3. What IPv4 address? 192.168.3.3. What type of traffic? HTTP or port 80. So with this statement, I'm permitting TCP host 192.168.2.22, which is PC2, accessing the website on a destination device, which is server 3, with the IPv4 address of 192.168.3.3. I want to deny TCP host. Which host? Server 2. What IPv4 address? 192.168.2.2. Accessing a destination device. Which device? Server 3. What IPv4 address? 192.168.3.3. What type of traffic? HTTP, EQ 80. So deny TCP host 192.168.2.2 host 192.168.3.3 prevents server 2 from accessing the website of server 3. I want to permit server 2 to ping server 3. ICMP is the protocol that is being used. ICMP host which host 192.168.2.2, pinging which host with destination host server 3, what IPv4 address 192.168.3.3, what type of traffic, echo. So permit ICMP host 192.168.2.2, host 192.168.3.3 echo will allow server 2 to ping server 3. I want to deny PC2 from pinging server 3. So the command is deny ICMP host 192.168.2.22 host 192.168.3.3 echo. If I just keep these 4 statements and nothing else, any other traffic will be denied all of G01 of the or into the G01 of the router 2. But I want to allow other types of traffic, maybe from other networks. So I add a permit IP any for traffics from other sources or any other traffic. I need to add this one because there is an implicit deny any at the end of each access list. I'm nullifying it by adding this command or statement. Then exit. I'm going to go to interface G01 of the router 2 because this is the closest interface to the source of traffic that I want to filter, and the direction of traffic from this network to router 2 is into the G01. So I'm going to apply the access control list that we created and we called it PC2-web-access. I'm going to apply to this interface with this command IP access dash group. Then I have to type the name of it, or in this case I can copy and paste it, and then I have to give the direction in. That's it. Now let's go ahead and put it to test. Let's see if we can access the website on server 3 from PC2. Based on access control list, we should be able. So we go to the web browser of PC2, and in the URL we type 192.168.3.3, which is the IPv4 address of server 3, and we can access that server's web page. See if we can ping server 3 from PC2. Based on access control list, we should not be able. Destination host unreachable. Let's go to server 2 and see if we can access the website on that server. Based on access control list, we should not be allowed. So we go to the browser of the server 2. We type the IPv4 address of the server 3 in the URL and see if we can access it. We should not be able. We most probably get a message as a timeout indicating that the access control list that we have prevents us from going to the website of server 2, going to the website of server 3 from source device of server 2. Let's see if we can ping server 3 from server 2. We allow that. Replies should come back as they are coming back. So let's go back to the router and perform a show command to show access dash list. Access has 2 C's. There you go. It shows that we have created a name extended IP. IP indicates IPv4 access control list with these five statements. The first statement, when traffic reaches router 2 through G01, router is going to read this statement. If it matches that traffic, it will apply and ignore everything else. Otherwise, it will go and read the second statement. If it matches, it will apply and ignore everything else. Otherwise, it will go and read the next statement. If it matches to the traffic that it has received, it will apply and ignore everything else. Otherwise, it will go and read next one to see if it matches the traffic that it has received or not. If it does, it will apply and ignore everything else. Otherwise, it will go to the next one. You see, this permit IP any uh, uh, allows traffic from other network to reach the network of PC2 and server 2. Without it, PCs in this network wouldn't be able to ping or access the website of server 2 or ping PC2. And that's how you create named extended IPv4 access control list and verify the configuration with show commands and ping. Now we want to create an extended IPv4 access control list to prevent anybody from pinging server 3. Ping could be used as a form of attacking a server and getting the server busy and and replying to the pings that are coming, and therefore not provide the service that is supposed to provide. So it is very important not to allow other devices ping servers such as server 3 and server 2 in this case. We are going to create a no ping access control list applied to G00 of both router 2 and router 3. First, we are going to go to router 2 and we go back to global configuration mode and create an access control list, a named one, IP access dash list extended. We call it no ping server 2, SVR2. And we are going to apply this command. ICMP host, we want to deny it, deny ICMP from any device to server 2, host 192.168.2.2 as far as the traffic is equal to echo. We want to permit IP any. Exit. Interface G00 IP access dash group. What was the name of it? No ping SVR2. Direction inward. That's it. Nobody should be allowed to ping server 2. Let's go to PC1A, destination host unreachable. Let's go to PC2, destination host unreachable. Let's go to server 3, ping 192.168.2.2, destination host unreachable. Let's see if we can ping PC2. Yes, we can. We only prevented people from pinging server 2. Replies are coming back. Replies are coming back. So we prevented any echo initiated by a device that attempted to ping this server to even get into this router. Now, on router 3, we are going to do it another way. We will go to the router 3. We access the privilege mode, show access dash list. There is no access list on it. We go to global configuration mode, conf t, and we are going to create IP access list extended. We call it no ping server 3, and we are going to deny from any host, any ICMP host, ICMP. Let's do it a different way. Deny ICMP host the IPv4 address of server 3, 192.168.3.3. Reply back to any as far as echo reply is concerned. Echo-reply. So people can ping server 3, but server 3, the reply from the server 3 is not going to get back to them. So I'm going to then permit IP any. So I did it a little bit different in here. So if this device pings server 3, the pings gets to the server 3 replies back, but the router is going to prevent it. I'm going to apply it to G01 in the inward direction. Exit. I'm going to apply to interface G00 in an upward direction so you can see the difference. Interface G00 IP access dash group. The name of it was no ping server 3 in the outward direction. So let's go ahead and see if we can ping server 3. Should prevent it because we have created an access control that wouldn't allow any ping reply back coming to PC1A from server 3. You notice the error message that you get, or the reply that you get, is different from when we didn't allow any echo go into this network. If we ping server 2, we receive destination host unreachable. But when we ping server 3, we receive request timed out. So which one is a better type of access control list? The one that we applied to the G01 of router 2 that would provide us with this error message is better. It does not even allow the ping to get to the server. It will kill it right there. But the one that we applied to G01 of router 3 would allow the ping to get to the server. Server will reply it back, but then the replies are getting back. We are preventing this device to receive any reply back, but any device can ping server 3 and make it be busy. Just server's replies do not get back to those devices. So the one that we applied in here at G01 with this command and applying it to G00 in an inward direction is much better than the one that we applied to router 3. But sometimes you have no other choice. So I've demonstrated on both one, either one that is suitable for your network. My preference is the one that I apply to router 2. You can do it. It's also possible to combine both echo and echo reply type of statements in one access control list. In some cases, you need to do that. That's how you create an extended no ping access control list. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.